Okay, so far we've learned a couple of methods for these algebraic style questions. Notice that both methods still rely on our regular physics. I still have my list of variables. I still have to use my equations. Nothing in terms of the physics has changed. Just the fact that there's no numbers can throw people. Now this last method uses ratios, and I find it works really, really well for any of these before and after questions. So in other words, person drops it from a height h. What happens if you double the height? This is a classic before and after question. What happens if? Method's the same. We write down all our variables and we start filling in the gaps. My initial velocity is 0, no matter what. I don't know v final. A, we're going to write as negative g. I'm going to keep it as generic as possible. Down, it means negative. Time, we don't know. And distance, we're going to write as negative h. And if I want to get an equation for t, once again, I want to find one without v final in it. And once again, I'm going to be forced to use this one. And as usual, because my initial velocity is 0, that goes away. So now when I plug in my variables, I get negative h for d equals 1/2 negative g times t squared. Now, continuing on, canceling off our negatives, I get h equals 1/2 g times t squared. Now here's the key to this ratio question. What are our variables? What changes from scenario A to scenario B in this equation? Well, certainly the height's going to change. It's twice as high in scenario B than it is scenario A. And the time of flight's going to change. The 1/2 g remains constant. So let's isolate the constants. Let's get all the constants by themselves. So if I get rid of the t squared from both sides, I get this. 1/2 g, which we know remains constant, equals h over t squared. In other words, this ratio, h over t squared, has to remain constant. That means the big H over its time of flight squared will be the same as the little h over its time of flight squared. And that's the ratio. So the ratio will look like this. Little h over, and I'll just call this time A, over time A squared is equal to big H over time, and notice I've labeled this side B, time B squared. These ratios both equal 1/2 g. So because they're constant, they have to be equal to each other. Now I just plug in the values. So a little bit of algebra now. So we're going to leave the one on the left as h, and we'll call that ta squared, not changing anything there. But they said that the second height, capital H, is twice as high as the first one. So I'm just going to replace this with 2h. Now notice what happens. We still adhere to our algebraic rules. Notice there's an h on both sides. They're both in the denominator. They both cancel. Now I'm trying to figure out how TB is related to TA. What is TB compared to TA? So now we got to solve it for TB. Get TB on top first. Multiply both sides by TB. In fact, let's multiply both sides by TB squared, just to get it completely out of there. So now I get TB squared over TA squared equals 2. Bring the TA squared up and over. Multiply both sides by TA squared. TB squared equals TA squared times 2. Take the square root of both sides, and I get TB is the square root of TA squared times 2. The square root of anything squared is just the variable itself. So the square root of TA squared is just TA. And I get the time of flight for scenario B is the same as scenario A times root 2. Now, if I do the same thing with my final velocities, you can get a little bit of practice here. You'll see a very similar result. So I'm going to do that in blue. Now, my final velocities, I'm going to have to make a little bit more space here. So give me a second. I'll erase some of this stuff. Let's see if I have enough room here. If I do my final velocities, avoid equations with t in it, I get this one. V final squared is V initial squared plus 2AD. Again, the initial velocity is 0. So I get an equation that says V final squared is 2 times negative g times negative h. The negatives cancel. I get V final squared is 2gh. Now, what are my variables? What changes from A to B? Well, they both have different final velocities and they both have different heights. The 2g is constant. So get the constant by itself. I get 2g is V final squared over h. Let me just fix that a little bit. So V final squared over h, that ratio must remain constant. And that's what I'm going to use to establish my equation. So the final velocity to fall in part A squared over its height is equal to the final velocity to fall in part B squared over its height, which was 2h. And once again, the h's cancel off. And you can see the pattern. I'm going to get V final B squared is 2V final A squared, and then square rooting both sides, I get the same answer that I get before. I get my final velocity in part B is root 2 times my final velocity in part A. I've always liked the ratio method for before and after scenarios because it kind of eliminates any of the guess and check, right? Seems to be a little bit cleaner, but it is a little more advanced with the algebra.